Howdy everyone, my name is Darshil Rayjada and today I'll present milestone 2 of my semester project, AetherMart Data Infrastructure as a part of course ISTM 622 Advanced Data Management. This milestone is about moving beyond a single relational database and exploring techniques like triggers, partitioning, and NoSQL concepts. I'll also discuss MariaDB ColumnStore, which is designed for analytics. So let's understand business case narrative. I think we already know because we worked on milestone one, but let's go through it quickly again. So at Ethermart, we identified three key people with pressing challenges. Maria Rodriguez, head of marketing and analytics, struggles to analyze unstructured data like product reviews, which don't fit neatly into relational tables. Second, Sarah Chen, head of product management, who needs a flexible schema so she can quickly add new digital services or expand product categories without breaking the database. And the third, David Miller, lead database architect, has to scale the database to handle millions of new record as the business grows. And why it's mandatory to design a scalable and adaptable data infrastructure that supports both transaction and analytics. So think of it like an Amazon. In its early days, they started with a relational database, but as their product catalog exploded, they had to embrace NoSQL and partitioning to keep performance under control, right? So today's our agenda will cover five main points: triggers, NoSQL conceptual analysis, MariaDB column store, partitioning, and then lessons and the next steps. Each piece of content connects back to solving Ethermart's real business problems. And yeah, this is the agenda I mentioned over here. So yeah, let's first understand triggers. A trigger is basically a rule you back into the database. It's like a safety net. The triggers fires automatically whenever an insert, update, or delete happens. Its purpose is to enforce business rules and prevent bad data. For Ethermart, triggers are critical because transactions come from multiple sales channels, like a website, mobile app, and maybe even third-party marketplaces, right? We don't know. If even one bad transaction slips through, it can corrupt reporting. For example, imagine if a review with a rating of 10 out of 5 got stored. Marketing might wrongly assume that customer satisfaction is sky high and we should increase our sale. But triggers stop that before it happens. So this is what the trigger do. I have explained theoretically definition, purpose, and business use case impact specifically for Ethermart over here. Trigger solution and demonstration. So I built two triggers. One checks that review ratings are always between 1 to 5, and another recalculates the order total whenever order item change. So think of it like a shopping on Amazon. When you add items into your cart, the total updates automatically. The triggers ensures the database matches what the consumer sees, even if multiple systems are involved. And this way, no matter how orders are processed, the data remains accurate. So yeah, I have created these two triggers. One is to check review rating before insert, and second is to update order total before insert or update. And I have mentioned business impact, which I just said, and demonstrations. So before go to operational impacts of trigger, let's first understand the demonstration. So I'll go to a VS Code. Okay. So I have explained all the three triggers, all the both the two triggers over here, and then the third is basically a tasting. I'll explain you that as well. So the first trigger, so when it runs before inserting a new row into the review table, and what it does is checks the rating column. If the new rating is less than 1 or greater than 5, it raises an error and blocks the insert. If rating is valid, which is between 1 to 5, the row is inserted normally. Okay. So, and the second trigger, again, when it runs is basically before updating a row in the orders table, looks up all order items linked into the order ID, and it will calculate the total as a sum, which is basically quantity into price per unit, and update new total amount to the computed value. And this will ensure that the total amount column is order is always consistent with the order items. And again, the thing to note over here is that this trigger will only runs on update, not on insert, right? And that's why the script forces an update later to fire it. Okay, so I'll explain you over here what I did on the MariaDB. Let's go. So you can see over here, I have inserted a dummy product and customer. So the review insert has a valid foreign key. Okay. And as soon as I insert rating of 4, right, which is between 1 to 5, the trigger insert succeeds. And if I enter rating of 6, the trigger fires as an error that insert is blocked, and will get an error message that rating must be between 1 to 5. So this is what my first trigger is. And for the second trigger, again, I have added a dummy order with a total of 0.00. Okay, over here it's dummy order with a 0.00. And then I have added one order item for quantity 5, as you can see, quantity 5, and price per unit is 20. So expected total should be 5 into 20, which is 100. And it will force an update, as you can see. So the trigger executes, and even though we have set it up a total of 1, right, over here we have set it up total of 1, uh, it will override the trigger, and it will give us a successful result, which is 105 into 20. So computed total come as a result. That means it's working correctly, right? And I'll explain you in a business case. So let's take an example of Maria Rodriguez. Needs a reliable data from customer reviews, so it's critical to prevent data from entering into the database. And the second example I would give for, like this section taste the trigger you created automatically calculate the total amount of an order. So AetherMart needs a accurate financial data, and manual errors in calculating an order's total. It can be costly, right? So this triggers automatically process that request, which will gonna save your cost. So yeah, let's go back to PPT and let's go to operational impact of trigger. So now triggers are very useful. We just checked, but they come with the cost. Every time a row is inserted or updated, the trigger logic also runs, adding overhead. This increased transaction time. For example, in a busy Black Friday sale, if every order insert also fires a complex trigger, the database could slow down. And in high concurrency systems like ticket booking, this might cause bottlenecks. So trigger are based for lightweight checks, not a heavy processing. And that's what mentioned over here, that it have a significant impact on how database operates. It can streamline process, but also introduce a complexity, and the complexity is as soon as trigger automatically execute, it can lead up to unexpected behavior. A single action can, set off chain of reaction before the final state of data predicts, and it will increase your complexity. Again, it dependency on database schema, right? So we must also consider their impact on the triggers. Pros and cons. So pros, automation reduces manual effort. Consistency is the thing that it will rules enforce at the database level, and security ensure that sensitive actions are logged. But the cons are, again, as I mentioned, debugging complexity, harder to maintain if many triggers overlap, and order of execution can cause unexpected results. So I'll explain you performance impact of triggers. So overhead on DML operations. So every time, whenever the DML statement will execute, the triggers must also be run, and it will again add a computational cost, and it will slow down your system. Triggers again extend the duration of transactions. So if a trigger performs complex logic, it, like querying to other tables also, while calling the procedure, it can significantly lock up the resource. Blocking issues, again, in ticketing system, as I mentioned, it will slow trigger, can cause other users process to wait, and it will lead application performance issue. I'll explain you a real world banking example over here. So imagine we have an orders table and a product inventory table. Every time someone buys a PlayStation, inventory should decrease by one. Instead of depending on application code, a trigger automatically updates the inventory table after an order is inserted. So this will ensure that stock is always accurate, preventing overselling or underselling. And companies like Walmart rely on such triggers to sync online stock with the warehouse inventory. So this was the e-commerce example. Sorry, my bad. I'll explain you the banking example now. So banking is like banks often use the triggers to ensure compliance, right? So, for example, a trigger might block a transactions over $10,000 unless a compliance check is logged. But banks must balance with the performance because millions of transactions happen every day. So, yeah, I explained the trigger, benefits, and impact, and also I have mentioned the e-commerce example. So now go to a NoSQL concept. So basically, traditional relational databases are great for structured data like tables with fixed columns, but AetherMart also has unstructured data, product reviews, tags, social interactions. That's where the NoSQL comes into the picture. So it's designed for flexible data and horizontal scalability instead of upgrading one powerful server. Again, in a vertical scaling, we can add more servers in horizontal scaling to share the load. So think of a Netflix. Their user data and recommendations are stored in NoSQL systems like Cassandra because relational databases couldn't scale fast enough. So motivation for NoSQL handling unstructured data. Horizontal scalability, as Ethernet grows, it needs a way to scale by adding more servers. A cap theorem. Okay, so it's very important. This fundamental theorem states that a distributed system can only guarantee two of the following three properties can be done. It's either consistency, availability, and partition tolerance. So for Ethermart's multi-channel strategy, availability and partition tolerance are crucial to prevent outages. This is key reason to consider NoSQL databases as they often prioritize these two properties. Okay. So types of NoSQL database, there are four types of NoSQL database: key value, column based, graph based, and document based. So key value stores like Redis or DynamoDB, perfect for coaching user sessions or shopping carts. Wide column stores like Cassandra, great for large scale analytics. Facebook Messenger also use a Cassandra for a messenger storage, just for the information. A document database, so like MongoDB ideal for storing product catalogs or reviews where fields vary. Many e-commerce platforms use a MongoDB for catalogs. Graph-based database, so it's useful for social networks or recommendation engines. LinkedIn use graph database to power people you may know, right? That people you may know recommendation. And each type exists because of the cap theorem trade-off. You can't have everything, so you have to pick what matters most for your business. So again, as Dr. Gamilian says, depends. Database types: consistency plus partition tolerance guarantees data accuracy. It will use for financial transaction, e-commerce, and banking. And availability per partition plus partition tolerance, it will guarantee you uptime and responsiveness. And it use cases in social media field, streaming service, and analytics dashboard. So it's a trade-off reason behind the rise of different NoSQL database models: Cassandra for AP, MongoDB for CP. So MariaDB ColumnStore, again a very important theoretical concept. So traditional InnoDB stores data row by row, which is fast for transactions but slow for analytics. Column store stores data column by column, so it's much faster for aggregations. For example, if Maria wants to run a query like average rating of all products in 2024, right? Column store only scans the rating column, not the entire row. For Ethermat, the best approach is hybrid. Use InnoDB for fast transactions and column store for heavy analytics, just like how retailers maintain separate OLTP and OLAP systems. So that's what mentioned in this slides: row based versus column based. row based, again, store data one row at a time. This is great for transactional operations where you need only read an entire record. Okay, and column based, it will store data one column at a time, and it will useful for analytical queries that often only needs access of few columns. How it works, I already explained you, and I'll show you in demonstration as well. But the key advantages is the architecture makes column store significantly faster for complex analytical queries, data aggregations, and business intelligence reporting. So MariaDB column store explanation. I already explained you column store, but let's go through once again. Column store is the column-based storage engine for MariaDB designed for analytical queries. Contrast this with row-based InnoDB engine, which is optimized for transactional workloads. Pro is again massive performance boost uh, for data aggregation. What does exactly Maria's team need? And cons, it not suitable for transactional workloads, so that's why we recommend a hybrid architecture using InnoDB for day-to-day transaction and column store for high-speed analytics. Data partitioning. So partitioning is like breaking a huge book into chapters. Instead of scanning all pages at once, you open only relevant chapter. For AetherMart, so we partition the orders table by year. So if queries 2024 cells, the database only looks at the 2024 partition instead of running whole record. This is called partition pruning, and it speeds up queries significantly. So, as I mentioned, data partitioning, horizontal partitioning is a database technique divides large table into smaller. And I already mentioned about query approach. I don't explain over here. Let's go quickly into MariaDB on the first on VS Code, and I'll explain you the code. Okay, so we want to check how many orders exist, their date range, and their distinct years. Okay, I have divided into five phases. I'll go one by one. So in phase one, this helps us detect, partition boundaries by a year. It will ensure the data completeness, show how many records have a valid order date, clean, needed for partitioning, right? So I have done pre-migration analysis and preparation, as you can see. Now in the phase two, I have created a partition tables with a new structure. So I have created a table order new, okay, with a composite primary key, order ID, order date clean. It requires since partition tables needs the partition key included in the primary key. Indexes again for a faster lookups by customer date or amount date. Partitioning by year of order date clean. So 2023 all orders, okay. 2024, 2025 and future anything after 2025. So it will move the clean data from orders into orders new in the phase 3 data migration. It will move the clean data from orders into orders new, and it will skips rows where order data clean is null. Okay. And yeah, now let's go before this is phase four is for tasting. So before I'll go over there, let me show you on the MariaDB. Okay. So I'll show you over here how we have tasted it. So I have tasted it. Select count star from orders new as migrated count, and then case when count star is equals to select count star from order new, then pass, otherwise it fails. So it will compare the record counts before and after migration, and it will give us an output pass or fail. So you can see my validation status is pass. That means it worked correctly. Okay, then we have tasted by a couple of more queries. So select orders as table underscore name, count, original count again, and then count star from orders new as migrated count, and then we have again mentioned a case when count is equal to select count star from new order table, then pass, otherwise fail. Oh, okay, this one I already explained you for pass and fail. I'll explain you this new one. So in this one, explain partitions. Okay, so to see which partitions are skinned, like because of partitioning, only P2024 should be skinned, not the entire table. So you can see P2023, again we don't have any rows, 2024, 2025, and future we don't have any rows. So 23 and 24 we got the rows. Again size MB is also mentioned. So this proves partition pruning is working correctly. We got all the order new in the order new table we got it by the year. Okay, and over here you can see I have just the same thing. I have did it between January 1, 2024 to 31st March 2024. How many rows are there? So it gave me 55,216 out of this in 2024, right? So, why this matters: without partitioning, queries would scan the whole orders table. With partitioning, queries only scan relevant partitions for a faster output, right? Looking for 2024 orders only hits P2024 over here, right? And this script prepares, creates, migrates, validate, and it's also performed, tested participant versions of the order table year by year, right? And it ensures that we queries run faster and database is easier to manage specifically for AetherMart, like in real world any type of businesses. So yeah, let's go back to again example on the PPT. So data partitioning, right? We were at the data partitioning demonstration. I've already explained you, and I'll give you one more example. Like in Spotify, partitions that use activity logs by time. So when they run reports like most streamed artists in July 2025, they only scan the month's data, not the entire history. Let's just think of the Spotify users and the data year by year, like how much big data it can be, right? So this technique is very useful in that. And we already verified by checking over there and performing that partitions a year by year. It's working correctly and it will reduce our workload and improve the performance. Okay. Hybrid architecture. So here's how it all fit together. Transactional data from the website and mobile app flows into InnoDB. Okay. Optimized for transaction, right? Periodically, an ETL pipeline moves the data into column store, optimized for analytics again. And this result is a hybrid system that supports both fast transactions and powerful analytics. So this is the same approach Amazon and Walmart use: OLTP for sales and OLAP for insights. So yeah, that's what mentioned over here, visual representation. This slide is best presented as a visual and describe how data flows from various sources, example e-commerce website, mobile app, and connecting the pieces. Explain how an ETL process would move a copy this data to a separate column store database for analytics and reporting. And just think of big picture. This visual demonstration is for understanding data infrastructure that supports both fast transactional and complex analytics. So yeah, summary. mm, we have successfully implemented triggers and horizontal partitioning, which has provided foundation for data integrity and scalability. I have also shown you NoSQL and column store to prepare for future challenges. What we learned is, data types and foreign key constraints and how it resolved. And yeah, MariaDB Milestone 3 project is yet to come. We're gonna discuss replication and clustering over there. AI user disclosure, very important. So, in large language model, a code generation, what I used is basically I used AI tools to assist with the generating SQL code and explanation, but I carefully validated and corrected the output to match MariaDB syntax and real business needs. So the lesson I learned is that AI is helpful as a co-pilot, but human judgment and testing remain essentials. And to wrap up, milestone 2 is implemented triggers for data integrity, partitioning for scalability and explode NoSQL, and column stored for flexibility and analytics. We faced real world challenges like handling foreign keys and data types, which taught us that theory uh, of and practices as well that don't always align. Planning is critical, and once the replication and clustering will come, which will improve availability and fault tolerance, much like how enterprise systems achieve a high uptime. So yeah, this is it for milestone 2 NoSQL and data distribution project. Thank you so much for listening to me. Sorry. If you have any questions, feel free to email me over here, darshil.rayjada@tamu.edu. Thank you once again. Bye. Have a nice day.